Okay, so now I have these files that are present with me. If I go to the material library and I check the FRC, so we have the lathe fibers and all these fibers, um, glass fiber, lead, steel fibers, and uh, these properties are present here. So in order to assign properties to it, either I have to use the material definition here, or either I have to use the material library. Since I have the material library, um, I can import these here, right, which have concrete and glass fiber, right, and lead steel fiber, right, and steel plate over here, right. So I have these, save changes, click on OK, and go to concrete properties. And in the concrete, I already have this compressive behavior for concrete of uh, approximately 61.8 MPa concrete here, and the tensile properties are given over here, and of course the concrete damage in terms of concrete damage plasticity is defined over here. For the glass fibers, I have the elastic and plastic properties that I have used here. And for the lead steel fibers, I have the elastic and plastic properties that I have used here. For the steel plate, I have these properties that I have used here. So I have to define these in terms of sections, just in case if I'm using these properties over here, right? So I have to define the sections for these properties, and the first section that I need to define is the complete section, right? And it will be a homogeneous entity. And similarly for the glass fiber or lead steel fibers, I have these glass fibers, right? Lead steel fibers, and this FR. I don't remember this FR, so I need to remove it from the parts, right? And let's just make it easier for myself. So let's go to properties, and we have this glass fiber, right? And for glass fiber, I have this beam truss consideration here because I'm considering them as a truss element. And let's say uh, their cross section area is 1 and 1 square, which is very less. Similarly, we have lead steel fiber, and let's consider them in this section, while for the steel plate I should consider them for the steel plate I should consider them homogeneous, right. And here we go, right. So we have these, and after this we need to assign sections to them. So make sure to uncheck this set and select it over here for the steel plate, and for the cylinder let's assign these, right. And for M1GF I will assign these properties for the glass fibers, and for the lathe waste I have to assign these properties, and for the top plate I have to assign these um, steel plate properties over here. So very easy to follow tutorial if you are watching it, and it's a widely used element in pavement and industrial floor, precast elements, tunnel lining, and repair works. So this enhanced toughness and crack resistance make it suitable for all these applications. So it's kind of a bridge for uh, your research to follow. So yeah, now I forgot one thing, that is partition them. And I think I should use the 3 point strategy over here. And point in normal will be fine. Why I did it here in this manner? Because I don't want to lose properties for this section, and of course for the cylinder. Sorry. Now let's do one thing more, that is like this, just in case if you want to enhance the machine more accurately. Then we need to go to assembly, and it gives us a warning. Some elements are deleted, which is obvious, so we have to delete these, switch it off, and after this, in assembly, for assembly we need two things to consider: uh, the reference point for the bottom and the reference point for the top, right? So for the top and bottom, we don't need datum. We can delete them. We should sorry, resume, and let's rename it with the base reference point, and rename it with top reference point, right? And I think we should try to create some faces for the cells. The easiest way to do is, instead of defining all those surfaces, etc., if we go to the interaction module, right? Um, no, first we need end assembly. We need to separate the instances, go to tools, set manager, and create concrete cylinder set, right? Done. And let's remove these and separate instances and go to fibers. I don't know if the spelling is correct or not. And let's go to tools and sets and manager again, and create a base RP set here. It will be base reference point, and top RP set here. This will be the top reference point, right? And um, we don't need anything else here. We need to go to the uh, step module, and in the step module we need to define a compression loading, right? It will be a static general, and consider it one switched on this specified dissipation energy 0.001. These are the control parameters that I most often use in my simulation, and one is fine. Let's keep them same, and let's go to general solver controls and go to edit them and make it 70, right? So um, in here I need to define something, but before that let's go to assembly and go to tool set manager and create whole geometry, right? So we need to be careful about this consideration here, because we are making a very simple model, and for that we need only a few of the vectors and scalar outputs that we need here. So for displacement, uh, for whole model, we can select something like this, uh, whole geometry, right? And similarly for stresses, we will select, uh, we, we need to select the minus stresses, these are okay, and go to set, and for the set I will consider complete cylinder, and of course strains. So for strains we need to go to set complete cylinders. Nah, sorry, let's do something interesting. Remove this and this, and then keep them like this. Go to tools, sets manager, and call it FRC, and select this whole assembly, right? And do one thing more. Remove these. Remove these instances. I think I have done this. If I go to tool set manager, yeah, that's been done. Let's go to edit this, and instead of uh, I should select FRC, and for strains I should select FRC as well, and I will plastic strain and equivalent plastic strains, and similarly damage in concrete. And for damage in concrete, I will select the set, the concrete cylinder, and I will select the damage T, and scalar degradation model, right? And I think this more than enough, but here I need to define two things, that is um, force and displacement curve here. So this is force, and for force we will select the set base, right? So base R, and we will consider RF2, and this will be displacement, and for displacement a set of top RP will be selected, and since our global direction is U2, so we are going to select base, right? Okay, now after that, I think we need to switch to introductions.